Well, basically a miracle happened. I left a message on the internet in one of the conferences, and it's actually a small conference on a page where the guy explains how to upgrade this radio, this exact circuit board. So I left a message, does anybody have the exact schematic for this? I said, I already had the Russian one. And this guy put a message up there. He goes, email me, and I'll send it to you. So I did. I emailed him, and he sent me the exact schematic. Okay? And where this picture comes from that's on the web page, this is from the Gerber files for the board. The guy actually sent me the Gerber files if I wanted to have one of these circuit boards made by a company. That's what I guess everybody's doing. I don't know if you have to pay any royalties. I really don't care at this point. So when I last left you, I was sending signals into the antenna and following them through, and they were like going to a place that didn't make sense. Okay, so I decided to take a long wire and use my old method. Oh, plus the board was going into oscillation on me. It was becoming very unstable because when I put the signal in, you got to hook grounds for the signal generator and a ground for the scope, and the board does not like that when it's outside of the case. So I said, let me use my old system. Now in this case, I ground down the points on the meter, and I used one of these with a wire on the end of it. And what happens is you use the signal you want to pick up through the air into the wire. So you set the radio for 1490 AM, which is a really strong station. And then you take this fine point and you go down near the mixer chip. And you hear the station. It's all garbled. And then you slowly work your way back. And having this schematic was really nice. Bing, 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 bing. I'm working my way back. Remember I told you this is a bunch of switching gates, like rotary switches. And anytime you go to a certain band, the microprocessor sends out a signal, and all these little miniature rotary switches turn, and they route the signal from the antenna either through the amplifier or bypass the amplifier down through a filter made out of one crappy little ferrite coil, down through another gate, and then into the mixer. So I'm coming down from the antenna, and it's like going to nowhere, not making any sense. And I'm testing each switching chip to make sure it's got its B plus and it's got its signals. Okay, so I'm down. Then keeps oscillating. It keeps going into whistling and oscillation. I said, all right, got to go use my old system. Disconnect everything from the radio, run it just like this off a switching supply, and then use this wire as a signal injection. The signal comes in on the wire, and work my way up. And all of a sudden I get to a chip, and when I go to the opposite side of the chip, the signal's coming out of the wrong pin. And I'm like, oh, no. I'm like, no. It's a misprint in the schematic. So I double and triple check it, and I'm like, okay, the signal's coming out of the wrong pin on the chip. So that means that there's two signals. I got it written here. I don't know if you can see this. Let's see if we actually see this. This is the actual chip. This is a PE42641, and it's like a rotary switch. Okay? And what controls the rotary switch are these two pins up here. And they change. When you change the band, these change. And then they route the signal out through this chip. Well, one of the control pins is not moving. Okay? It's staying low all the time. Now, there's a couple different things. The chip is shorted. The trace going back to the microprocessor is shorted to ground somehow. There's a short at the microprocessor, or the microprocessor is bad. That's where I'm at right now. So, it's just a matter of getting my ohm meter, which like I said, I cut these pins down nice, and ohming back the wires, make sure the schematic's correct, and then figure out why the one pin. Now, what I did was I put my meter in voltage mode, grounded it to the circuit, and I can actually see that control signal. And I can change bands with the radio. And you see that signal go high and low. But the one pin, it just sits low. So it's either shorted or the micro is bad. Okay, or there could be it could be a broken trace too, you know. But that's where I'm at now. I'm about 20 minutes from finishing. Okay, now I'm going to tell you, if you don't see another video, this is scrap. It's that simple. Here's the chip here. What is there, 80 pins on that thing? Super tiny, close. I guess it's possible to send this board to someone and have them change the chip for me. But think about this. This thing was $120, $127. The guy that sold it is a real jerk. He changed the ad now on the eBay. He's got his like a lot of the other ones, you know. Oh well, we'll send you this. Yeah, we'll send you the board, the unit with worthless Chinese software on it, and then you'll get it, and it'll be basically a brick. And then you can pay more money to the guy that really is responsible for the radio, and he'll pay you, or you'll pay him, and he'll give you the way to flash it so it works like it should have worked in the first place. But that's where I'm at now. But what did I learn out of this? Basically nothing. I really thank this guy. I think his name was Don or Dan. He sent me the schematics, which made me be able to go through this a lot neater, a lot quicker. And then, you know, you're absolutely sure when you're changing the bands, you can actually watch the signals going to these chips. And there's 3 chips, and there's 2 pins on each chip. That's 6 pins, okay? And out of the microprocessor, those 6 pins change, and they route the signal like through a bunch of gates. You picture water, you know, you can like irrigation water valves, and you can change the settings of valves in order to route the water in one area or route the water in the other. And think of the water as a signal. Okay? Well, in this case, this radio is routing the water to one place, and the rest of the circuit is expecting the water to be in a different place. Okay? It's that simple. But technically, you know, this thing's real tiny. It's hard to see. And that's why this morning I ground the pins, the probe pins back so they could do these tiny little things. Now, years ago we had triplet meters, little tiny triplet meters, and they had the most nastiest probes on the end. They were like needles, and they were for real small work. The meter was real tiny too, and that's why I said, you know, let me just grind these Radio Shack things down and put a nice tip on it so I can go between the pins. And doing the continuity is very easy, okay? And I know exactly what chip is messed up now, and then I know that the signal comes from this chip over here. So it's a matter of, the first thing you do is you make sure that you have connections from the chip that doesn't work right to the micro. And then once you got those 2, it's only 2 pins, one of the pins works. So you go back, you make sure you got continuity. Then you take the continuity from each pin to ground. And you should see some resistance. You're measuring the inside of the IC chip. And if you're real lucky, you'll find one pin is really grounded, even though the thing's off. It's not at a low. It's not at a high. It's just sitting at a certain amount of resistance. When it's dead shorted to ground, the IC could be bad or the micro could be bad. So you go with cutting the trace going into the cheapest chip, and then you check again. You don't cut the pin off the micro, okay? You cut the pin, the trace next to the pin of the chip, okay? You don't cut the pin on the chip, and the reason for that is it's very easy to scrape that little cut you made, scrape it, and you bridge a little piece of very fine wire that's been tinned across it after you tin the trace, and that's how I operate. But I got a feeling the micro's bad. You know, originally I was hoping, up until about 12 o'clock noon today, I thought I actually had a bad ferrite bead in that one amplifier. But then I started following it back, and all of a sudden I'm like, the signal's coming out of the wrong pin of the chip. And you say, well, how could that happen? Well, it's got the wrong logic switch. So when you don't have a high on a pin and you have a low, what happens is the signal is routed out of a different pin, and I found it. And like I said, now it's just a matter of taking a break and putting the last 20 minutes into it and double checking everything, you know. But if you don't see another video, I gave up. Okay, You say, well, John, you never gave up before. You know, I really asked for this, okay? Uh, this was supposed to be something I sat at the end of the day and relaxed with. Ha, that's funny how that is now. But this thing has been bad since it's been manufactured. And it could be a solder bridge somewhere on those two wires. And having the real schematics has really made it so I was going in circles on this thing. You know, the signal was coming in from the antenna all the way down into here. And there's the chip. It was right in, I was already back here, down through, right to there. And what's happening is this chip here wants to get the signal over here from up in here. But it's got the wrong pin turned on because the logic of this micro back here is wrong. It's pretty interesting stuff, okay? But unfortunately, you know, I'm like, I won't say I have $500. Yeah, I have about $500 worth of time into troubleshooting this, okay? I got it last Wednesday, and Wednesday night I kind of played with it, thought I was doing something wrong, and then I decided to flash it. That took several days. That has nothing to do with the time. And then I think I'm on 2 days of troubleshooting at this point. I'm losing track, you know. But I kept hoping it was going to be something simple, you know. But life's not like that. But if this was bigger in size and that was a standard microprocessor, I'd order one. I'd double check to make sure I'm right. Then I'd order a chip. But this gets removed with hot air, and then you lift it up, and then you double check all the pads, and then the new one's tinned. You make sure the pads are all tinned. There's a little bit of flux. I don't know if you ever watched that guy. What he does, he fixes cell phones. I can't think of his name right now, but I used to watch him. He has all the equipment, all right, and he's got the knowledge, and he always gets a cell phone that's been worked on by somebody else. You know, it's like Shango, 66. He gets a lot of bodge stuff. I get bodge stuff, okay, but this thing here. I don't know if it's been refurbished and resent. These two chips here, they've been changed. So I don't know if someone's repacked this up and then shipped it out and sold it to me. And like I said, the guy changed his page. It was so misleading. And then if you read his reviews on eBay, everybody says he's misleading. He's a sneak, okay? And he's a typical. I think that's it. All right, that's it.